Hi, this is Richard C. I'm a math tutor here at Wyzant. This is a question submitted by a student who's probably taking pre-calculus. It involves adding two vectors. The sum of two vectors is called the resultant, and you can see there that vocabulary is being used there. So the first vector is north 30 degrees west, so that means it's going to look like this. And this is going to be a 60-degree angle here. So it's north. We have north, south, east, and west here, obviously. And 30 degrees west means you start due north and then you move over toward the west 30 degrees, which will leave you with a 60-degree angle here, reference angle of 60. And then this length is 1640. And then we have another vector that's south 60 degrees west, so it's south, and then 60 degrees west, so that means it's going to make a 30-degree angle here. You face south and then you pivot 60 degrees west, and that's going to create another vector here, and the magnitude of this other vector is 1260. Okay, so we're just going to imagine these 30, 60, 90 triangles here. So there's one of them here. There's another one here. And we'll just fill in the coordinates of the vector up here. So let me just make a little diagram just to refresh your memory about the 30, 60, 90. So if you have a 30, 60, 90, apologize for my horrible handwriting. So you can see that in this diagram, 1640 is 2A. So opposite the 30 up here is, so here's my 30. Opposite the 30 is half of that, so that's 820. See how opposite the 30 is half the hypotenuse. And so this height here has to be 820. 820 root 3. So the coordinate of this vector here, is negative 820, comma 820 root 3, like that. And we're going to do take a similar look here. The hypotenuse is 1260, so opposite the 30 will be half of that, which would be 630. So the coordinate here is, and then this is going to be 630 root 3 along here. So it's negative 630 root 3, comma, negative 630. Okay. So if we want the resultant R is just going to be, and these are supposed to have like square brackets here. So it's going to be the resultant. Actually, let me use a different color here. So the resultant R is going to be equal to, we just add these together, negative 8 820 plus, or let me just say, minus 630 root 3, comma, 820 root 3 minus 630. Okay. So the resultant vector is going to be, now we'll just do, we'll convert everything to decimals. So 630 times the square root of 3 and we'll add that to 820. So I get negative 1911.19, let's say, comma, then 820 times the square root of 3, and then we're going to subtract from that 630, and I'm left with 790.28. Okay. And they want to know the magnitude here. So the magnitude of R. So this is really just Pythagorean theorem. If your teacher hasn't explained that or maybe gave you a complicated explanation, it's really not complicated. If we were to draw R, then we should do that. So negative 1900, so that's going to be pretty far out here. 1900 and then up 790. So it's going to be not as high as this one. This one was 820, so roughly here. So that's roughly the resultant vector R. And that's exactly what you would expect. Both of these vectors are pulling to the left, they're pulling westward, and so the resultant is going to be that much stronger in the westward direction. But the vertical offset is a little bit bigger because the vertical here is 830, the vertical here is 630. So the resulting is 790. So it's just not pulling it as much vertically as it was originally. Okay, so if we want this, we're just going to get negative 1911.19 squared plus 790.28 squared. And although I rounded it on the screen, I can go back to my calculator and just cut and paste here. So I had 1911 for the first answer, and I'm going to square that. Then I'm going to add it to the other 790. So I cut and paste that, square that. Okay, and then I'm going to take the square root of that result, and I get 206.8 point. I can round the final answer to the nearest hundredth, so that's 1.4, and this would be in kilograms. Okay, so you can see the size or magnitude of the resultant is bigger than the original size or magnitude of each of these vectors that comprise the resultant. And that's not surprising because they're both pulling in the general sort of westerly, at least they're both pulling westerly and there is a little bit of a reduction because in the size of the resultant, because this one is pulling vertically more than the other one is pulling vertically, so they don't offset each other vertically that much. Okay, so that's it. That's all you have to do. So when you're doing the vectors, usually in pre-calculus, you get to vectors after you've figured out everything you need to know about trigonometry. So this is really just using your trigonometry to come up with the solution to this question. Vectors are used extensively in physics, so if you take physics, you'll find that these come in handy. Okay, so that's it for this question. I hope this was helpful to you. See you again next time. Bye-bye.